Welcome to our channel Sankalp Study Success. Today in this lecture, we are going to learn about Unit 4, which is a new unit again. And in this chapter, we are going to see about test of hypothesis. This is one of the easiest chapter in our MSF subject, in which we are going to have same kind of problems so that it will be very easy to solve. So let us do it one by one. Now, what is test of hypothesis? In this chapter, we are going to see about some of the important terms which are null hypothesis and alternate hypothesis. These are the most important things from which we are going to do the problems based on null hypothesis and alternate hypothesis. So now coming from the starting, statistical hypothesis. What is statistical hypothesis? Generally, it is an assumption about a population parameter. You are going to assume. Generally, we know hypothesis is nothing but it is just an assumption. Even null hypothesis and alternate hypothesis are just assumptions which we take it, and at the end we are going to prove whether our assumption is true or whether our assumption is false. That means whether we are accepting it or whether we are rejecting it. Now, let us see from here what is null hypothesis and alternate hypothesis. It is the hypothesis which is tested for possible rejection under the assumption that it is true. That means we are going to assume that the given statement is true. That means we are going to assume the statement is true, but it is tested for possible rejection. We will see whether it is rejected or whether it is accepted. And this null hypothesis is denoted by H0. H0 is the symbol which you denote for null hypothesis, and alternate hypothesis you will denote it by H1, and which is exactly opposite to the null hypothesis. It is any hypothesis which contradicts the null hypothesis. Here whatever the statement you assume in the null hypothesis, exactly the reverse of the statement will be assumed in the alternate hypothesis. And here you are going to contradict the statement of null hypothesis, and we will denote alternate hypothesis using H1. Here, based on this, we are going to have types of errors. That means error type 1 and error type 2. Let us see here, the type 1 error is nothing but if we reject the null hypothesis when it should be accepted. Whenever the statement of null hypothesis it should be accepted, at that time if we reject it, then we will say that it is a type 1 error. So, exactly opposite to the type 1 error, that means whenever the null hypothesis it should be rejected, then at that time if you accept it, then it is known as type 2 error. That means whenever it should be accepted, you are going to reject it, and whenever it should be rejected, at that time you are going to accept it. These are some of the errors based on the null hypothesis. That means these are the type 1 and type 2 error. So now let us see what is critical region. Critical region can also be said as region of rejection. That means there is a statement. If you are accepting the statement, then it will not come under critical region. If you are rejecting the statement, that means the region where you are rejecting that statement or the range where you are rejecting that statement, that is known as critical region. So here, a region in the sample space S which amounts to rejection of H0 is called critical region, or it is known as region of rejection. Wherever the statement or the expression or the equation is going to be rejected, that is known as a critical region. Now, exactly opposite to the region of rejection is nothing but the acceptance region. That means the region which is not covered by the rejection region is the acceptance region, right? So, if for example there is a curve where this is nothing but the region of rejection, that means critical region. Let us suppose, this is just for an example, if this is the region of rejection, then the remaining region which is not covered by the region of rejection is known as acceptance region. That means this is the region which is not covered by the rejection, right? So that means this region is known as acceptance region, which is a very easy topic, which is the region which is not covered by the rejection region, then that region is known as acceptance region. Now, the value of a test statistic which separates the critical region and acceptance region is called critical value or significant value. That means there is acceptance region and the rejection region. Rejection. See here, the value which is separating both the rejection region and the acceptance region, that value is known as critical value. Or this critical value can also be called as significant value. It is nothing but significant value. That means the value, it is just separating the acceptance region and the rejection region. Rejection region can also be said as critical region. So it is separating critical region and acceptance region. So that value is known as critical value or the significant value. So now let us come into two-tailed test. What is a two-tailed test? Here, whenever this is H1 is nothing but alternate hypothesis. H0 is nothing but null hypothesis. Whenever an alternate hypothesis it is not equal, then that is known as a two-tailed test. That means here null hypothesis is nothing but theta is equals to theta naught or theta 1. Let us suppose whatever it is a value of theta is equals to theta naught. So alternate hypothesis is nothing but which is exactly reverse to the null hypothesis, where theta is not equals to theta naught. This is one case. For example, alternate hypothesis may also become theta greater than theta naught or theta less than theta naught. That means this, whenever it is not equals to theta naught, then that is known as two-tailed test. But in these two cases, this is not known as two-tailed test. So you have to remember which is exactly opposite to the null hypothesis, then it will become a two-tailed test. If theta is equals to theta naught in the null hypothesis, then in the alternate hypothesis, it should be theta naught equals to theta naught. Then we can conclude it as two-tailed test. If not, if in case theta is greater than or less than theta naught, then that's in such cases we are not going to consider it as two-tailed test. So here we will be having rejection region, acceptance region, critical values, because if there is a rejection region and acceptance region, then there will be a value which is going to separate both the regions. That value is known as critical value. And also you are going to calculate test statistic values. Now let us see what are the test statistic values and how are we going to calculate them and all. So now here there is a two-tailed test. We have just seen it, which is nothing but theta is not equals to theta naught. And we have also seen two more cases where theta is greater than theta naught and also theta is less than theta naught. These all are nothing but H1. That means alternate hypothesis. When null hypothesis becomes theta is equals to theta naught, then alternate hypothesis, we are going to have three cases in which we have just seen this, which is nothing but two-tailed test. Now let us see what are we going to do for theta greater than theta naught and as well as theta less than theta naught. Here left-tailed test and right-tailed test. We are going to have left-tailed test and right-tailed test, which are nothing but if theta is less than theta naught, then you are going to say it as left-tailed test, and if theta is greater than theta naught, then we are going to say it as right-tailed test. So that means if null hypothesis is theta is equals to theta naught, for example, that means if for example theta is equals to 50. If theta is not equals to 50, then this is nothing but the two-tailed test. If theta is greater than 50, then it is nothing but right-tailed test. If theta is less than 50, then it is left-tailed test. So in this way, you are going to consider whether the given one is two-tailed, left-tailed or right-tailed. So here we have seen with the theta naught, if theta is not equals to theta naught, then it is a two-tailed test. If theta is greater than theta naught, then it is a right-tailed test. If theta is less than theta naught, then it is a left-tailed test. So in this way, we are going to consider these three cases. Now, let us see how to calculate. That means what is the procedure for testing of hypothesis. Here, in the testing of hypothesis, we are going to first of all we consider null hypothesis. That means H naught. The first one we are going to do is H naught. That means if theta is equals to theta naught, or if theta naught value is already given, then we are going to substitute in it. So in that way, we are going to first define the null hypothesis. Then immediately we are going to define or specify an appropriate alternate hypothesis. So second one is nothing but H1, where immediately after considering null hypothesis, then you are going to specify alternate hypothesis. Now, level of significance. Level of significance is nothing but it is denoted by alpha, which is already given in the question itself. If alpha is not defined in the question, then you are going to consider it as 5% by default. So value of alpha will be 5% if it is not given in the question. So now coming to the fourth one, here we are going to state an appropriate test statistic and draw the figure. So along with the figure, you are going to calculate the test statistics. That means according to the question, we are going to take the test statistic. There are 4 types of questions in this chapter. So let us see one by one. So in the 4 types of problems, we are going to have 4 different types of test statistics. So we need to state an appropriate test statistic. That's the reason we are going to say here appropriate. That means we are going to have 4 different types of problems. So you have to first of all identify which type of problem is given, so that you can easily apply an appropriate test statistic. So then we are going to calculate the Z value under the null hypothesis. So if you calculate the Z value, from where do we calculate the Z value? From the test statistic. Okay. Now state the rejection region for the test statistic. Now we are going to state the rejection region in the 6th step. Then compare the calculated value with tabulated Z value. That means what? We are going to have the Z distribution table. In that Z distribution table, we will be having the values of Z alpha by 2 or Z alpha according to the question. That means here, we are going to calculate the Z value. That calculated value will be compared with the tabulated value. That means in the Z distribution table, we are going to have Z alpha value and Z alpha by 2 value. So according to the question, if we are going to take Z alpha, then compare the Z calculated value with the Z alpha tabulated value, or if we are going to have Z alpha by 2, then we are going to compare the calculated value of Z with the tabulated value of Z alpha by 2. Then we have to decide whether H0 is accepted or it is rejected. So we have to decide. So what are those 5 steps which we are going to do is, first we are going to specify the null hypothesis, then we are going to specify alternate hypothesis, then the level of significance, which is alpha already given in the question, then we are going to calculate test statistics, appropriate test statistics, right? Then we are going to compare. First we need to find out the calculated Z value, then we are going to compare. The last one is compare. We are going to compare the calculated value with the tabulated Z value. Then at the last, we are going to decide whether it is accepted or rejected. That means null hypothesis is accepted or rejected. Now let us see how these all steps are going to have. Now, test of hypothesis concerning our mean. Now let us see. let H naught is mu is equals to mu naught. This is nothing but the null hypothesis. So for each null hypothesis, we are going to have 3 cases where mu is not equal to mu naught. Then we have already just now learnt it, which is nothing but two-tailed test. And if mu is greater than mu naught, then it is right-tailed test. And if mu is less than mu naught, then it is a left-tailed test. So now, let x bar be the mean of a random sample of size n taken from a normal population with mean mu naught and standard deviation sigma. That means what? X bar is the mean of random sample whose size is n, and normal population has the mean of mu naught and sigma. These are nothing but all the values which are given in the question. Then the test statistic will become, this is the formula where z is equals to x bar minus mu naught by sigma by root n. This is nothing but the value of z. In this way, using this formula, we are going to calculate the z value, where x bar is the mean of random sample. X bar is the mean and mu naught is the mean of normal population. Taken, see, size n taken from normal population with mean mu naught. That means population mean is nothing but mu naught and sigma is nothing but standard deviation, and here n is the size of the sample, right? Size of random sample is n. So in this way, by substituting all the values in the given formula, we are going to calculate the z value. Now, critical regions for testing mu is equals to mu naught. How do we test, or how do we decide whether the hypothesis is rejected or accepted? Let us see. Alternate hypothesis H1 reject null hypothesis when mu is not equals to mu naught, that is for two-tailed test. If the given question is a two-tailed test, then if the calculated value is less than the tabulated z alpha by 2 value, minus z alpha by 2, or you can take it as calculated value is greater than positive z alpha by 2, then alternate hypothesis H1 rejects null hypothesis. Here, this is for two-tailed test. This is for right-tailed and left-tailed. If for right-tailed, mu is greater than mu naught. We have already seen it. If for this right-tailed test, if calculated value is greater than z alpha, then the alternative hypothesis rejects null hypothesis. In the same way, left-tailed test, that is mu less than mu naught, it is, in this case, z calculated value of z will be less than minus tabulated value of z alpha. So these are the 3 cases when alternate hypothesis will reject null hypothesis. Here we are going to have the critical values of z, which are the standard values for 1%, 5% and 10%. That means these are the values taken from the z distribution table. In the z distribution table, you will be having these values. Here we have given directly for level of significance of 1%. That means if alpha value is 1%, which is if 1% is given in the question, then you will consider as 0.01, because 1% is nothing but which is equals to 1 by 100. That means it is nothing but 0.01, and if alpha is equals to 5%, if it is given, then it is nothing but 5 by 100, which is going to become 0.05, and if alpha is equals to 10%, that means it is 10 by 100, then it is nothing but 0.1. So in this case, in this way, we are going to take the values of level of significance. And if it is for two-tailed test, then z alpha by 2 value is 2.58 for 1%. See, this is a table. So now this becomes for z alpha by 2, two-tailed test. In the case of two-tailed test, the value of z alpha by 2 for 1% of level of significance is 2.58. So z alpha by 2 value for 5% is 1.96 and 1.645. So in this way, we are going to have for two-tailed, right-tailed and left-tailed test. These are the standard values which we are going to take, but they are also known as the tabulated values actually. So now let us see we have discussed there are 4 types of problems or 4 types of test statistics, right? So now let us see all the 4 types one by one. The first one is test of significance of single mean. This is the first one. From here we are going to have the problems for each type. So now it is the most important thing where we need to concentrate. Now this is nothing but for single mean. It is test of significance of single mean. This is for large sample. Okay, that means n should be greater than 30, right? If n is greater than 30, then it is a large sample, and if n is less than 30, then it is a small sample. So now let us see the working procedure of single mean. Here, just now we have seen how we are going to specify step by step, right? In the same way, here the first step is nothing but null hypothesis H0. Here H0, how do we take H0? Set up H0 for given data as mu is equals to mu naught. This is nothing but H0, that is null hypothesis. Now immediately we will specify alternate hypothesis. This alternate hypothesis for given data will become mu is not equal to mu naught. Why? Because alternative hypothesis is exactly reverse of null hypothesis. So that's the reason we are going to have exactly opposite. Mu is not equals to mu naught. And if it is a left tailed and right tailed, then mu will be greater than or less than mu naught according to the question. Now the step 3 is nothing but alpha, which is level of significance, value of alpha, which is already given in the question. See here, set alpha for given data. Now if alpha is not given in the data, then we need to consider it as 5%. We have discussed previously. So if it is not mentioned in the question, alpha value is not at all mentioned, then we are going to take 5% by default. So coming to the step 4, test statistics. Here this is the formula with z value, which is we need to calculate. That means calculated z value for single mean is x bar minus mu by sigma by root n, where this is the important formula because for single mean problems we are going to calculate the z value using this formula. Here x bar is nothing but sample mean, mu is the population mean. There is a difference between x bar and mu. It is the sample mean and population mean. Sigma is the population standard deviance, and n is the size of the sample or sample size. So in this way you are going to substitute all the values in the formula, then we are going to get the calculated z value. Now we are going to decide whether the null hypothesis is accepted or rejected. So conclusion, we are going to compare z alpha by 2 or z alpha with the calculated value at level of significance. Given level of significance we are going to consider. That means what? At this level of significance we are going to compare the values of z alpha by 2 with these z alpha by 2 values. That means we are going to compare calculated z value with these z alpha by 2 values. So if the calculated value is less than z alpha by 2, if the calculated value is less than z alpha by 2, this is less than, then we are going to accept H0. That means what? Accept null hypothesis. If calculated value, that means you have calculated mod z value, it is greater than z alpha by 2, then reject null hypothesis. In this way we are going to compare and we will decide whether null hypothesis is accepted or rejected. So this is the procedure to solve the problems of test of significance of single mean. First we are going to consider the null hypothesis, then we are going to specify alternative hypothesis and level of significance which is given in the question itself. If it is not specified, then consider the value of alpha as 5%. And now test statistics. Formula of z is x bar minus mu by sigma by root n, where all the values of x bar, mu, sigma and n will be mentioned in the question, so that you can substitute in the z value, so that you can substitute in the z formula and get the calculated value of z. Then compare the calculated value with z. If the z calculated value is less than z alpha by 2 or if calculated value is greater than Z alpha by 2, then you will reject or accept it. So if it is less than, then you will accept. If it is greater than, then you will reject. So this is the procedure to solve the problems. Now let us see the problems here. It is claimed that a random sample of 100 tires, that means let us write the given data. It is claimed that a random sample of 100 tires with mean lifetime of 15 to 69 kilometers. That means what? N is equals to 100 tires because it is the sample size, right? N is equals to 100. And here it is given that mean lifetime of 15 to 69. That means what? Mean lifetime, which is nothing but X bar, 15 to 69 kilometers, right? Is drawn from population of tires which has mean lifetime of 15 to 100 kilometers. That is, it is nothing but the population mean, which is equals to 15 to 100 kilometers. And we are going to have standard deviation, which is nothing but sigma, right? Sigma is equals to 1248 kilometers. Then test the validity of the claim at 1%. That means what? Alpha is equals to 1%. Or 1% which is given, and construct 99% confidence interval. This is the question. That means first you have to test the validity. That means whether it is accepted or rejected, you have to decide. Then you have to calculate the confidence interval as well. So here we will go step by step. So the step 1, which is nothing but the null hypothesis. In the exam, you need to write it step by step so that we can score more marks. Step 1 is null hypothesis, where it is denoted by H naught, right? Here mu is equals to mu naught. It is nothing but 15 to 100. So let us write mu is equals to 15 to 100 because mu naught value is already given in the question. Here, then step 2. Immediately we are going to specify alternate hypothesis. So alternate hypothesis, which is exactly opposite to the null hypothesis, right? That means H1 is mu is not is equals to 15 to 100. That means mu is not equal to mu naught. That means mu is not equals to 15 to 100. 15,200. Now step 3. Which is nothing but level of significance, which is alpha. Alpha is already given in the question, so alpha is equals to 1%. Now coming to the step 4, which is test statistic. Test statistics. Here the Z is equals to X bar minus mu by sigma by root n. This is the formula which we have for Z. So let us substitute all these values in Z so that we can get the calculated value of Z here. That means X bar is equals to 15269 minus 15200 by sigma by root n. Sigma is nothing but 1248 by root n. That means square root of 100, which is nothing but 10, right? So if you calculate this using calculator, then you will get it as Z is equals to 0.55. Now in the step 5 we are going to compare. So here step 5. In the step 5, which is nothing but conclusion, let us give it as conclusion. Here mod Z value, which is equals to, just now we got it as 0.55. So here it is 0.55 and Z alpha by 2 value, because why we are considering alpha by 2? Because it is a two-tailed test. Here mu is not equals to mu naught. So Z alpha by 2 value, which is from the tabulated value, it is 2.58, right? Let us verify it. Here Z alpha by 2 value for 1% level of significance, it is 2.58. So we are going to take 2.58 here. That means what? Here mod Z value, it is less than Z alpha by 2, right? Because 0.55, it is less than 2.58. That means what? If it is less than, if calculated value is less than the tabulated value, then null hypothesis is accepted. Therefore, null hypothesis is accepted. So in this way, we are going to decide whether the null hypothesis is accepted or rejected. So we are done with the problem, but here construct 99% confidence interval. So we have to construct confidence interval also. That what is confidence interval actually? Confidence interval. Here the formula of confidence interval goes like this: x bar minus z alpha by 2 sigma by root n, comma x bar plus z alpha by 2 sigma by root n. This is the formula of confidence interval. In this formula, if you substitute all the values, then you are going to get confidence interval. That means x bar is nothing but 15269 minus z alpha by 2 is nothing but 2.58. Just now we have verified it also. So into sigma by root n. Sigma is nothing but 1248 by square root of 100, comma, here let us write it here, 15269 plus 2.58 into 1248 by square root of 100. This is the confidence interval. So if you calculate these values, that means if you simplify these values, then you will get it as let us write it here, 14149.016, comma, here if you calculate this value, that means the second term, you are going to get it as 15590.984. So this is nothing but the confidence interval for 99% of level of significance. 99% level of significance is nothing but which is equals to 1%, right? Because 99% or 1%, which is same for level of significance. If it is given 95% or 5%, then both are one and the same. So in this way, you are going to calculate the confidence interval for the given question. Now let us solve one more question for single mean. Here the length of life of certain computers is normally distributed with mean and standard deviation. See here, mean and the standard deviation are given. If random sample of 30 computers has average life of 788 hours. Now let us write the given data. Here given, let us write it here, n is equals to, it is not random sample of 30 computers actually, it is of 300 computers. So now let us take the n value as, it is actually 30, right? So let us erase it here. Because it is a large sample. If note this point because it is very important. If n is greater than or equals to 30, then it is a large sample, or if it is n less than 30, then it is a small sample. So here n is equals to 30, which is nothing but a large sample. So we can consider it for the single mean. N is equals to 30, and here x bar is nothing but 788, right? Because it is average life of 30 computers. So x bar is equals to 788 hours. You have to write the units also. So now here we are given with mean and standard deviation, where mu and sigma, mu is equals to 800 hours and sigma is equals to 40 hours. So this is the given data, and we need to also know what is level of significance, right? That means here the level of significance is equals to, we are given with test the validity of data at 1% and 5%. That means for 1% you have to calculate for the first time, and for the 5% you are going to calculate it for the second time. That means level of significance will become 1% and also 5%. That means for the two cases we are going to test the validity. So here let us solve it for 1% as well as 5%. So now the first step is null hypothesis. That means let us write it as NH, which is null hypothesis, where H naught is nothing but mu is equals to mu naught. Mu naught is nothing but 800, which is already given. So it is null hypothesis. Now coming to step 2, which is alternate hypothesis, here which is exactly opposite to the null hypothesis, that is mu is not equals to 800, where mu not equal to mu naught, right? Here now coming to step 3, which is level of significance, that is alpha value. Here alpha is equals to 1% and alpha is equals to 5%. So now let us calculate test statistics for the given question. That means test statistics is nothing but z is equals to step 4. Here z is equals to x bar minus mu by sigma by root n. That means what? X bar is nothing but 788 minus 800 by sigma by root n, 40 by square root of 30. So if you calculate this z value, then you will get it as minus 1.643. Because 788 is less than 800, right? So we are going to get the negative value minus 1.643. Now let us compare calculated value with the tabulated value in the step 5, so that we can say whether the null hypothesis is accepted or rejected. So in the step 5, mod z, if it is mod z value is nothing but 643, right? Because mod, we are taking the mod of the value so that we can take the positive value. So z alpha by 2, for we are going to check it for 1%. Z alpha by 2 for 1%. Here let us write in the brackets 1%. So for 1%, Z alpha by 2 value is nothing but 2.58. So here mod Z is less than Z alpha by 2. Right? That means null hypothesis is accepted. So Z alpha by 2 for 5%. Let us see it for 5%. For 5%, the value of Z alpha by 2 is nothing but 1.96. So here it is 1, right? 1.96. Where 1.643, it is again less than 1.96, right? So mod Z is less than Z alpha by 2 even for 5% of level of significance. That means here also H naught is accepted. That means null hypothesis is accepted. So therefore we can say that null hypothesis is accepted for both 1% and 5% of level of significance. So in this way we are going to conclude, and also here we have to construct confidence intervals for both 99% and 95%. That means both for 1% and 5% of level of significance. So now let us calculate confidence interval. The formula of confidence interval, we have just now seen it, x bar minus Z alpha by 2 sigma by root n, comma x bar plus Z alpha by 2 sigma by root n. So now here we have to do it for alpha is equals to 1% as well as alpha is equals to 5%. But here let us suppose it is for alpha is equals to 1%. So if alpha is equals to 1%, let us substitute all these values, and also Z alpha by 2, it is for level of significance of 1%. That means here x bar is nothing but 788 minus 1% for level of significance, it is 2.58 into 40 by square root of 30, comma, here it is the term which is having the just plus sign, 2.58 into 40 by square root of 30. So now if you simplify this value, then you are going to get it as 769.158, 806.841. This is the confidence interval for 1% of level of significance. Now we are going to also calculate for alpha is equals to 5%. So which is of same formula, x bar minus Z alpha by 2 sigma by root n x bar plus z alpha by 2 sigma by root n. So now let us substitute 788 minus z alpha by 2 value is nothing but 1.96 for 5% level of significance, and here 40 by square root of 30 comma 788 plus 1.96 into 40 by square root of 30. Now if you simplify these values, then you will get it as 773.686 comma 802.313. This is nothing but the level of significance for 5%. This is the confidence interval value. So in this way you are going to find out all the values for single mean, test of significance of single mean. So this is of the first type. Now let us see what is of second type, which is test of significance of means of two large samples. Mean of two large samples. Previously we have seen it is for single mean. Here we are going to see for two means. So that means this is of type 2. Now here x1 bar and x2 bar are sample means of two independent large samples. That means we are going to have two large samples of n1 and n2 where the mean becomes x1 bar and x2 bar. That means we are going to have two means in these kind of problems. That means in second type problems we are going to have two means, two population means as well as two standard deviations. That means mu1 mu2 and sigma 1 sigma 2. So here the same steps follows for all the four types of problems. That means for step 1 here we are going to have null hypothesis, which is nothing but h0. Here mu1 is equals to mu2 because previously we were having only one mu. So in that case we are going to consider mu equals to mu0. But here we are having two means. So here we will consider it as mu1 is equals to mu2. And alternate hypothesis will become exactly opposite to null hypothesis where mu1 will not be equal to mu2. So here alternate hypothesis mu1 not equals to mu2, there is some significance difference between two population means. That means mu1 equals to mu2 means what? The values of mu1 and mu2 are equal. But in the case of alternate hypothesis, if the values are different, then we are going to say that mu1 is not equal to mu2. So there will be some significance difference between mu1 and mu2. Now coming to the third step, which is level of significance alpha, which will be given in the question. The same thing repeats here. If it is not given in the question, you are going to consider the value of alpha as 5%. Then coming to the test statistic Z. Here the Z, formula of Z will be changed because it is for two means. It becomes x1 bar minus x2 bar divided by square root of sigma 1 square by root n1 plus sigma 2 square by root n2. There will be a whole square root for the denominator. So by applying all the values of x1 bar, x2 bar, sigma 1, sigma 2 and n1 and n2 in the given formula, then you will get the calculated value of Z. So in the next step we are going to compare calculated value of Z with the tabulated value. That means each and every step will be the same in all the four types of problems. But in the first type we are going to have only single mean. Here we are having two means. That's the difference. And here in the comparison, if mod Z is less than Z alpha by 2, then you are going to accept it. If mod Z is greater than Z alpha by 2, then you are going to reject H0. That means the comparison is also same for the first type and the second type. Just the formula is different. That means test statistic is different. Here, for example, if sigma 1 square and sigma 2 square are equal, that means value of sigma 1 square and sigma 2 square are equal, then the formula will become, if you take the sigma as common, then x1 bar minus x2 bar by sigma of square root of 1 by root n1, 1 by n1 plus 1 by n2. That means here, if you will just take the sigma as common, then you will get the following, then you will get the formula as x1 bar minus x2 bar by n1 1 by n1 plus 1 by n2. Actually, I think there is no square root here in the formula. We are not having a square root. It is a small mistake that is here. So let us rectify it here itself. So that here the formula is z is equals to x1 bar minus x2 bar by square root of sigma 1 square by n1 plus sigma 2 square by n2. So this is the actual formula for calculating z value for two means. Now let us see the problems related to two means. Here, in a random sample of 100 tube lights produced by A has a mean life of this much with continuous standard deviation. That means this is completely of the first one. And the random sample of 75 tube lights, that means this is N2, which is having a mean life and also standard deviation. Here we are going to test the significance of A and B. Now let us write the given data. Given n1 and n2, sigma 1, sigma 2, mu 1 and mu, that means x1 bar and x2 bar. So now let us write n1 is equals to 100, n2 is equals to 75, right? Here x1 bar is nothing but 1190 and x2 bar becomes 230, right? This is the value of mean life, yeah. Then sigma 1 becomes 120 and sigma 2 becomes, sorry, this is sigma 2, right? Then what is sigma 1 here? Sigma 1 is 90. Okay. So sigma 1 is 90 and sigma 2 becomes 120. So we are having all the values of n1, n2, x1 bar, x2 bar and sigma 1 and sigma 2. Now let us substitute all the values in the formula. So that means let us go step by step. The first step 1 is nothing but null hypothesis, where mu 1 is equals to mu 2. And alternative hypothesis becomes exactly opposite, where mu 1 is not equals to mu 2, which is step 2. Here, then the step 3 will become alpha, level of significance, that is nothing but alpha. If you observe in the question, alpha is not specified. That means we are going to take alpha value as 5%. Okay, if alpha value is not specified in the question, then we are going to take alpha value as 5%. Here, coming to the step 4, which is test statistics, let us write the formula of z, which is equals to x1 bar minus x2 bar by square root of sigma 1 square by n1 plus sigma 2 square by n2, which is the formula of two means. That is, here let us substitute all the values and then calculate. Z is equals to x1 bar is 1190 minus x2 bar is 230 divided by square root of sigma 1 square is nothing but 90 square divided by 100 plus sigma 2 square is 120 square by 75, where here these values we are going to substitute in the given formula. So if you substitute, then the z value will become 2.42. If you calculate this value using calculator, then you will get it as 2.42. Now the step 5 is the comparison between the calculated value and the tabulated value. So now let us see step 5, where mod z value, just now we got it as 2.42 and z alpha by 2 value at 5% level of significance, right? Because we have taken level of significance alpha is equals to 5%, which is nothing but 1.96 here for 5%. That means calculated value is greater than the tabulated value. That means here we can say that null hypothesis is rejected. Here null hypothesis is rejected. So we can conclude the test of significance difference between A and B. here null hypothesis is rejected. That means we are going to do the same steps for each and every problem, but the test statistic will be different according to the question. We are going to take the test statistic and then we are going to compare calculated value with the tabulated value. So in this way we are going to solve type 2 problems which are having of 2 means. Now let us see one more question here. The means of 2 large samples of sizes. Here the sizes are given. So now let us write the given data. Given N1 is equals to 1000 and N2 is equals to 2000. Where 67.5 and 68. That means means. These are the means. That means the means of 2 large samples of sizes are given and means are also given, which is x1 bar and x2 bar. x1 bar is 67.5 and x2 bar is 68. So now test the validity of data at 5% level of significance. Level of significance, that is alpha, is equals to 5%, which is mentioned in the question here. If samples are drawn from same population with sigma is equals to 2.5, that means there is no sigma 1 and sigma 2. Both the values of sigma 1 and sigma 2 are nothing but 2.5, which is given as sigma. That means you can also write it in this way: sigma 1 is equal to sigma 2 is equal to sigma, which is nothing but 2.5. Now let us test the significance. That means let us decide whether it is accepted or rejected. So now let us go step by step, where step 1 is nothing but the null hypothesis, where you will consider mu1 is equals to mu2, right? That, yeah, it is true. Mu1 is equals to mu2, which you will assume. Then alternate hypothesis will be exactly opposite to null hypothesis, where you will consider mu1 is not is equal to mu2. So here coming to step 3, which is nothing but level of significance alpha. Alpha value is nothing but 5%, which is already given in the question. Now let us calculate the z value, which is step 4, that is test statistics. Here you need to write the names of the steps also should be specified in the solution. So test statistic is nothing but the z value, where z is equals to x1 bar minus x2 bar divided by square root of sigma 1 square by n1 plus sigma 2 square by n2. In this case, sigma 1 and sigma 2 are one and the same. So x1 bar minus x2 bar by, if you take sigma as common, it becomes 1 by n1 plus 1 by n2. So in this formula, if you substitute all these values, then you will get the calculated value of z. Now let us substitute. Z is equals to x1 bar and x2 bar are the 67.5 and 68 by sigma value is nothing but 2.5 into square root of 1 by n1 plus 1 by n2. That means 1 by 1000 plus 1 by 2000. So if you calculate this value, then you will get it as 5.16. So this is the value of test statistics. Now let us compare the calculated value with the tabulated value in the step 5, which is nothing but conclusion. Here mod z value, we got it as 5.16 and z alpha by 2 for 5% of level of significance. The value is 1.96, right? That means here the calculated value is greater than the tabulated value. So you can say that therefore H0 is rejected, that is null hypothesis is rejected. So in this way we are going to specify whether it is rejected or accepted. That means null hypothesis is rejected or accepted. So these are the problems related to type 2. You will be having the same problems just with the different values. So you have to identify the type of the problem. That means if there is only single mean given in the question or two means are given in the question. So by that you can specify it as type 1 and type 2. Then if you apply the formula and you compare, then you will get the value. Now let us go into type 3, which is nothing but test of significance for single proportion. That means here there is a large sample of size n. So here, if you consider a large sample of size n which has a proportion p, that means small p is nothing but the sample proportion. Here you are going to have to test the hypothesis. Let us see what are the steps we are going to follow for single proportion. Till now we have seen for single mean and two means. Now we are going to see for single proportion and two proportions. Here H0, which is nothing but null hypothesis. The same steps will be followed for each and every type. So H0, which is null hypothesis where P is equals to P0, and H1, which is nothing but alternate hypothesis where P is not equals to P0. Because H0 and H1 will be exactly opposite to each other. So now, level of significance alpha will be given in the question itself. If it is not specified in the question, you will take it as 5%. Then coming to the test statistics, here the formula of z, here that means you will calculate this z value, which is nothing but a calculated value, is equals to small p minus capital P by square root of pq by n. Here small p is nothing but sample proportion, and here p, small p, how you will define small p? The value of small p will be x by n, which is nothing but number of success by number of observations in sample. If you solve the problem, then you will come to know and it will be much more clear. So here small p is the sample proportion. Here capital P is nothing but the population proportion of success. This is P is for success and Q is for failure. That means what? If P is for success, then it becomes 1 minus P. Q value will become 1 minus P. So in this way, we are going to calculate the Z value for single proportion. Then here the confidence interval will be changed, right? Confidence interval for population proportion at a given level of significance. What will be the confidence interval is P minus Z alpha by 2 into square root of PQ by N and P plus Z alpha by 2 into square root of PQ by N, where this Z alpha by 2 into here Z alpha by 2 into square root of PQ by N, this value is nothing but error of proportion. This is the error value, and if you consider just square root of PQ by N, then this is the standard error. So for 1 mark question, we are going to have 1 mark questions, right, in the part A. So in the 1 mark questions, if they specify standard error or if they ask about the error, then using these formula, you have to just substitute all the given values in these formula so that you will get the standard error, as well as if error of proportion is asked, then you have to substitute in this formula so that you will score easily. That means these are the problems which you may expect for 1 mark questions from 4th unit. So now let us solve some of the problems related to single proportion. Here a college management claims that 80% of single women appointed for teaching job get married and left the job within 2 years. That means let us write the given data. So 80% of all the single women appointed for teaching job get married and left the job within 2 years. And then test the hypothesis at 5% level of significance, which is already given 5%, among 200 such teachers. That means what? N is equals to 200. And 112 got married within 2 years and left their job. 112 got married. That means what? X value is 112. Got married and left the job after 2 years. So we are going to calculate small p value, which is nothing but x by n, right? Previously we have seen p value is nothing but x by n here. So x value and the n value will be already given in the question, and you have to just find out the p value, which is nothing but 112 by 200. That means the p value becomes 0.56. So now we are having the p value, and here 80% of single woman appointed. That means 80% is the success rate. That is, capital P is nothing but it is the proportion of success, which is equals to 80%. That means 0.80. Then Q becomes 1 minus P, which is equals to 1 minus 0.80. Then you will get it as 0.2. This is nothing but the Q value. Now we are having both P, Q, N and also small p, right? Now let us go step by step, where step 1 is nothing but the null hypothesis, which is H naught, which specifies P is equals to P naught, right? Where P value is equals to 0.56, correct? Sorry, we have to take the capital P value, right? P is equals to P naught. Here, see here, P is equals to P naught, which is the capital P value. That means P is equals to, we are going to take 0.80 or 0.8 if you consider. Now coming to step 2, which is equals to alternate hypothesis, where H1 is P is not equals to 0.8, because null hypothesis and alternate hypothesis are exactly opposite, right? Now coming to step 3, which is level of significance alpha, which is already given in the question, which is 5%. Now we have to calculate the Z value. Step 4, test statistics, where Z is equals to small p minus capital P by PQ by square root of PQ by N, right? Now let us substitute. Small p value is 0.56 minus capital P value is 0.80 divided by 0.80 into 0.2 by N value is nothing but 200. So square root of this value. Now if you simplify, if you calculate this, then you will get it as minus 8.48. So this is the calculated value of Z. Now let us compare calculated value with the tabulated value. Here, step 5, which is conclusion. Mod Z value, we got it as 8.48, and Z alpha by 2 value for 5% level of significance, right, which is equals to 1.96. Here mod Z, that means calculated value is greater than Z alpha by 2. That means therefore null hypothesis is rejected. So in this way we will conclude that null hypothesis is rejected. So using the test statistic formula, we are going to specify whether the null hypothesis is accepted or rejected. So now let us solve one more problem related to single proportion. That is, a company claims that 95% of the products can meet customer expectations. That means this is the probability, 95%. An examination of 500 products, that means N value is nothing but 500, right? So let us write the given one. Here 500 products are tested and 80 are found to be defective. Here, see here, 500 products. Actually now let us take it as 200 products, because it is the too high and 80 is too low, because you have to solve x by n. That means you will completely get it in zeros, right? So if you take 200, then I think it will be correct. So n value is nothing but the 200 products and x value is nothing but 80, because 80 are defective. So now let us find p is equals to x by n, which is nothing but 80 by 200, which is equals to 0.4, right? Now, given that level of significance is 0.05, which is nothing but 5%. So, level of significance alpha is equals to 0.05, which is 5%. Here, the capital P value is given as 0.95, right? Because 95% is the success. So, Q value becomes 1 minus P, which is 1 minus 0.95, which becomes 0.05. This is the Q value. So this is the complete given data from the question. Now let us solve it step by step. Here step 1 is nothing but null hypothesis, where P is equals to P naught, where P is equals to 0.95. Correct? Now let us see step 2, which is alternate hypothesis, which is nothing but P is not equals to P naught. That is, P is not equals to 0.95. Coming to step 3, which is level of significance alpha, which is already given in the question, which is 5%. Now let us find out the test statistics, that is the Z value. Here small p minus capital P by square root of PQ by N. Now let us substitute all the given values in the formula so that Z is equals to small p value is nothing but 0.4 minus 0.95 divided by 0.95 into Q value is nothing but 0.05 divided by here N. N is nothing but 200. So here we will substitute 200. Now if you calculate this value, then you will get it as 35.68. This is the calculated value of Z. So now let us conclude step 5, which is conclusion. Mod Z value is nothing but 35.68, which we got it just now, and the calculated, that means this is the calculated value, and here Z alpha by 2 value at 5% level of significance, right? That means 1.96. Here from this you can easily say that mod Z value is greater than Z alpha by 2. Therefore, null hypothesis is rejected in this case. So in this way, you are going to specify null hypothesis is rejected or accepted. So now, let us go into the last type, which we have the test of significance difference between two proportions. This is nothing but the fourth type, right? We are done with the single mean and two means, and also we are done with the single proportion, and we are going to see two proportions. And here we are considering two large samples N1 and N2 because it is of two proportions. We will be having the two values. So here the null hypothesis becomes P1 equals to P2. Then alternative hypothesis will become P1 is not equal to P2 because alternate hypothesis, which is exactly opposite to null hypothesis. And here the third step is nothing but the level of significance, which will be given in the question, which is alpha. If it is not specified in the question, then we will take it as 5%. Here Z value is equals to P1 minus P2 by square root of PQ into 1 by N1 plus 1 by N2, which is nothing but this to calculate the Z value. Here P1 minus P2, it is divided by PQ into 1 by N1 plus 1 by N2, which is having the whole square root in the denominator. Using this formula, we are going to calculate the Z value for two proportions. So P1 and P2 are the sample proportions. P1 is nothing but x1 by n1 and P2 is equals to x2 by n2. So here we are having P1 and P2, and also in this case we are going to solve capital P, where n1 P1 plus n2 P2 divided by n1 plus n2. This is the formula for capital P, which is of success rate. So obviously the failure rate will become 1 minus P. Q value will become 1 minus P. So using all these formulas, we are going to calculate test statistics. So the fifth step will obviously become the comparison between calculated value and the tabulated value from Z alpha by 2. So now let us see some of the problems related to fourth type. Here 100 articles from a factory are examined and 10 are found to be defective. And 1500 similar articles from a second factory are examined and 15 are found to be defective. Now let us write given data. N1 and N2. N1 is nothing but 100 articles. N2 is nothing but 500 similar articles. Right here 500 similar articles, which is nothing but N2. And X1 is equals to 10 because 10 are found to be defective. Here X2 equals to 15. Now let us find P1 and P2. X1 by N1, which is equals to 10 by 100, which is nothing but 0.1. P2 is equals to X2 by N2, which is 15 by 500, which becomes 0.03. Now we are going to find out the value of P, which is equals to X1 plus X2 by N1 plus N2. That is the formula of P. Here X1 plus X2 is nothing but 10 plus 15 by 100 plus 500. Which is nothing but 600, right? So here this becomes 0.0416. Here the Q value is 1 minus P, which is 1 minus 0.0416. Here if you calculate this, then you will get it as 0.9584. This is the complete value which is given in the question. Now let us solve it step by step. Here step 1, which is nothing but null hypothesis. H0, we will assume that P1 is equals to P2. Coming to step 2, which is alternate hypothesis. H1, here P1 is not equals to P2 because alternate hypothesis, which is exactly opposite to the null hypothesis. Now step 3, which is nothing but level of significance. Here if you observe, there is no level of significance given in the question. So let us take alpha is equals to 5%. Now step 4 becomes test statistics, right? Step 4, here the formula becomes Z is equals to P1 minus P2 by square root of PQ of 1 by N1 plus 1 by N2. If you substitute all these values, then we will get the calculated value of Z. That means 0.1 minus 0.03 divided by square root of 0.0416 into 0.9584 into 1 by 100 plus 1 by 500. So this is the square root. So if you calculate this value, then you will get it as 3.2. Now let us conclude with step 5, which is conclusion. Here we have mod Z value as 3.2 and Z alpha by 2 for 5% level of significance, which is nothing but 1.96. That means here you can say that mod Z value is greater than Z by 2, therefore H0 is rejected. In this way, we are going to solve the problems of two proportions. So we are having 4 types of problems. We are following all the 5 same steps in each and every type, but we have to check whether appropriate test statistic is applied to the given question or not. In this way, you are going to solve these problems, which are very important. You may get it for long answers from unit 4. So it is better to practice all these 4 types of problems. So thank you for watching the video.